Okay, so this is the last section of Graphs 7, Unit 8. And we're looking at solving nonlinear simultaneous equations graphically. Yuck, what a mouthful. But it's okay. It's actually, I think it's slightly easier than the first two sections of this entire, of this unit, actually. Simply because we don't really have to manipulate our equations too much, not like we have to in the previous ones. So I'm just going to jump straight in on, question. I'm going to go to page 224, exercise 4, and I'm going to start with question 1. And it says solve the simultaneous equations graphically from drawing from the graphs of this. So it's got y equals 4 minus x squared and y equals 1 plus 2x. Now, if you're feeling confident, you can sketch this graph, but I think we're going to actually plot the graph instead. So I'm going to go from x is -4, -3, -2, -1, 0, 1, 2, 3, 4, and y equals. I'm going to do this first one here. Well, -4 is -4 squared is 16, so 4 minus 16 is going to be -12. 4 minus 9 is going to be -5. 4 minus 4 is 0. That's nice. Then 4 minus 1 is 3. That's going to be 4. And then it's the same on the other side because it's symmetric. Okay, so this is nice because I can now plot this graph using my super duper pen of power. And I do it about here. Remember, it doesn't matter how you plot your graphs. It doesn't always have to be a cross. I'm doing it like this because it makes a bit more sense. That's going to be 2, that's 4, that's -2, that's 3, 3, and then I've got -5, 1, 2, 3, 4, 5, and then -12, 6, 7, 8, 9, 10, 11, 12. Okay, there and there. So I'm just gonna sketch this in. Okay, and then the other way. Okay, so that's my negative parabola. And now I'm going to I'm going to sketch the other graph, y equals 1 plus 2x. If you want to plot it, that's fine. I'm not going to, because I know that my y-intercept is going to be that 1 there, and I know that my gradient is going to be 2. So if I go across 1, I go up 2. And I can already see something a bit cheeky coming on here. I can see it going through there like that. Okay, so that's my other graph, and the solution to these two simultaneous equations are simply where the graphs meet. Because remember, all the points on a graph are just solutions to an equation, and the place where the solution, i.e. x and y, are the same for both equations happen at this point and this point because they're the same coordinates. So it must be our solution. Now, for this, you don't have to put in an actual perfect number because you are doing this graphically. I mean, the first one's quite nice and easy because I can see from here that it's going to be x is 1, y is 3. And for the second one, x is going to be -3, -5, I think. And those are my two coordinates. And it's really important also, don't forget to do this. You have to actually write your answers. Usually in the exam, there's a space for you to write them, but you've got to remember to write those answers. Otherwise, you don't get the final marks, which is very annoying, but true. Let's go to question 2. Okay, we've got y equals x squared plus 2x minus 1. And, oh, this is a bit different. 1 plus 3x minus y equals 0. Now, this one here, I'm just going to start with this one because I want to be able to draw that graph, but it's not in my normal way. It doesn't look like y equals mx plus c, where m is the gradient, as you all remember, and c is the y-intercept. It doesn't look like that at the moment, but I can get it into that form, if you will, by adding y to both sides. And if I do that, I get 1 plus 3x equals y. And if I want, I can, just to make myself feel a bit more comfortable, I can write y equals 3x plus 1. Now that looks exactly like our equation for a straight line, where our gradient is 1 and our y-intercept is, our gradient is 3 and our y-intercept is 1. The quadratic, on the other hand, is no idea what that looks like. So let's plot that as well. Right, so we're going to have x from -4 again. So -4, -3, -2, -1, 0, 1, 2, 3, 4. I'm actually going to do the positives because it's easier than doing, oh no, hang on, I can't do that. Right, let's do them one by one. Okay, so I've got, actually, how about this? If I do x squared, that's 16, 9, 4, 1, 0, 1, 4, 9, 16. I don't have my calculator to hand at the moment. My daughter was playing with it, and she doesn't know where she's put it. Never mind. But what I can do is I can do 2x. That's -8, -6, -4, -2, 0, 2, 4, 6, 8. And then I can just -1. -1 is always going to be -1. It doesn't matter what x is, it's always going to be -1. But now what I can do is I can just add these three numbers together. So 16 minus 8 minus 1 is 7. 9 minus 6 is 3, minus 1 is 2. 4 minus 4 minus 1 is 0, -1. 1 minus 2 is -2. Minus 1 is -3. Aha, right. And then -1, and then -3. Ooh, that's, have I done that right? Yeah, I have. 1 plus 2 is 3. Minus 1 is 2. 4 plus 4 minus 1 is 7. 9 plus 6, 15. Minus 1 is 14. And 16 plus 8 is 24. Minus 1 is 23. Okay. So I can plot those out. Now, to save just a little bit of time, I'm going to use my friend Desmos. Yay, because everyone loves Desmos. So your graph should look something like this. But what we need to see is the two places where the graphs meet. So we've got this one, and we've got this place right here. And sometimes it gives whole numbers answers. Other times it doesn't give a whole number answer. Obviously, when you're in an exam, you don't have the benefit of being able to use a graphical calculator or an iPad or something like that. So unfortunately, we just have to do our best and read what we can. So here I can see that x is -1 and y is -2 and 2 and 7. -1 and 2. -1 and 2. Oh, hello, Jasmine. -1 and 2. -1 and 2. Okay, so that's what I would have seen from my graph, where the two graphs overlap. Those are my solutions to my equation. So yeah, that's it really. I mean, you can obviously carry on practicing as many of these as you want or can. I would highly recommend any of the equations which aren't in the form y equals some function of x. So, for example, if I look at question 4, for example, that says x squared, oops, that says x squared plus y equals 4. Well, I'd rearrange it to y equals 4 minus x squared, just by taking away x squared from both sides, just because that makes it easier to draw the graph. Um, I I can't see that immediately looks like that graph right here, because that's what that graph is. But I can. That to me just looks a lot easier, and it makes it a lot easier to plot as well. So, but by all means, I mean, you don't have to do that. I mean, you can say, okay, well, if for something like this, well, if x equals if x, just choose the different numbers for x. If x equals -4, then 16, which is -4 squared, plus y equals 4. Therefore, y equals -12. So you can do it that way as well. It's just finding solutions to your equation, and therefore finding coordinates. The the writing it out in a box like this, so you're doing your plotting that way, I think is inherently just a little bit easier. This one, where you're just finding solutions to your equation, that does also work. So that also does work. Let's just do this one as well. X is -3, so it's 9, which is -3 squared, plus y equals 4. Therefore, y equals -5. Yeah, so we can find out our solutions and our plots points from doing that as well. Okay, there's lots of practice in this unit. It's really, really important just that you can manipulate those equations and just really see and understand how they work together. If you're able to do that, then you're absolutely solid. And you need to be solid at doing those things, especially for later chapters when we get onto things like graphing trigonometric graphs, things like that. But once you're really comfortable with, as I said, equations and how graphs work and what they are, then it makes everything else a hell of a lot easier. Okay, right. Well, enjoy your practice, and I will see you on the flip side. Bye.